Hi students, let's look at this question here, which was taken from the year 2019. VJC paper 2 question 9. This question is hypothesis testing. So let's see how we can do this proficiently. So you're told that the exposure of VOC, which have been identified in indoor air, is suspected to cause headaches and respiratory systems. Alright, so in indoor plants have not only a positive psychological effects on humans, but may also improve the air quality. Okay, great. So let's see, a commonly known VOC is benzene. The following data give the benzene level. 40 test chambers containing the indoor plant. I'm not sure what is this, epiremum aerium. Okay, so initially the mean benzene level without this was found to be 26. Okay, that's pretty okay. Now the question now is test at 5% level significance, whether it has decreased. Okay, so let this be basically this is a population mean, right? We assume. So as a result of the indoor plant, you should say your hypothesis clearly. Okay, so the indoor plants, you want to test the effectiveness of it, right? So that's the reason why you need to use this to test it out. So let mu, so just as usual, let mu be the population mean of the mu is actually the benzene level of benzene level. Okay, in X in ppm. Okay, great. So this is the first thing, and basically now once this is done, we could actually just let X H now. Basically, initially it was 26.0, right? So you want to test whether it has decreased. So it's less than 26.0. Okay. So this is a sample of 40. This is a sample of 40, meaning to say this is our sample data. We want to test whether it has decreased by looking at this sample data here. Let's see how we can actually find what is our X bar, meaning to say a sample mean. So n is equals to 40, after which we have n40 and summation of x minus 26.0 equals to negative 30.1. Alright, so that's pretty okay. So once that's done, what we need to do is actually to find, and also summation of x minus 26.0 squared is 214.61. So this case here, once done, what we're going to do is actually just find the x bar. X bar would be, okay, if you're confused, what we can do is just expand this out. This will be summation of x minus summation of 26, right? But summation of mean x bar will just be this is actually summation of x minus summation of 26. 30.1. Alright, so you could actually add it up. This case here, what you're going to get is actually minus 30.1 divided by 40 plus 26. Okay, so you key in calculator, this would just give us 25.2475. Great. Now once we are done with that, we're going to find the unbiased estimate of population. Unbiased estimate of population variance, right? So this is S squared. Using the formula, we have 1 over 40 minus 1 bracket this square, so it's 214.61 square minus negative 31.1 square over 40. Okay, so I think this is pretty okay. Once this is done, what we can get is 4.9220. Okay, you can just key in calculator because this is what we need to find. The p-value from calculator is actually 0.015 4.969. We could actually just calculate it. So just key in calculator for the p-value. Key everything in. Should be able to get answer there. So bring our calculator and basically go to stats and just calculate, right? Test 1 and go to stats here. Mu would be mu is actually 26, and sigma will be square root of the S value that you found, which is 4.9220, and after which we have got the X bar, which is 25.2475, and we have got 40 sample size. Okay, so that's about it. I think once that's done, we just going to lesser than. We're looking at lesser than, and I'm gonna draw this out. Hold on, this over here. Calculate it out. So the p-value is 0.15969. This is from GC. P-value is equals to 0.015969, which is actually equal to 0.0160, which is actually don't really need that, but it's less than the percentage. Alpha percentage is actually 5%, so this is less than 5%. Okay, so the conclusion is basically since p-value is less than significant level, okay, so H0 is rejected. At 5% level of significance, there is a sufficient there is sufficient evidence to state that the mean benzene level has decreased. Okay, that's it. So you need to be able to state, because now you reject H now and you're in favor of H, the alternative hypothesis. So in other words, it just means that that there's a decrease in the, you're in favor of H1, there's a decrease. So for the second part, you're told to state whether there's any there's a need to make any assumption about the population distribution of the benzene level in order to test to be valid. Because the sample size is large, so by central limit theorem, the mean benzene level will just follow a normal distribution. So you don't need, there's no need for any kind of assumption. So just let me type it out for part 2. Part 2, okay. There is no need to make any assumptions, as the sample size is 40, which is large. Okay, by central limit theorem, the sample mean benzene level will be normally distributed approximately. Okay, so the sample mean, as long as the sample mean becomes a normal distribution, then we are happy with, don't really need to do any assumptions. Okay, so let's look at part 3. So part 3 is you're told that the benzene level of another 50 test chambers containing the indoor plant were recorded. The sample mean is X bar, and the sample variance is 8.33. So this is important. I think many times students get confused of this part here. This is sample variance, meaning this is actually just sigma x 8.33. Okay, you're given the sample variance, so in other words, you need to find use this formula here, S square is equals to n minus 1 sigma x square. So unbiased estimate of population variance is actually n over n minus 1 sigma x square sample mean. Okay, so unbiased estimate of population variance is equals to n over n minus 1 sample variance. Okay, so this is important. So typically this is something which students have problem understanding. So you have n is 50, so it's 50 over 50 minus 1. So because sample variance, so sigma square x, sorry, so sigma x square is 8.33. So just key in this and you'll get 8.5. Okay, now if you're confused, what you should do is you should try and understand and draw the diagram out. You are told that actually H now is mu. It's the same test hypothesis that you did for the first two parts. So H1 acceptance region of the test is where bar x more than 25.1. State the alternate hypothesis to find levels. Another sample mean, so this will be the same test which is less than 26.0. After which so just take note, the population is not distributed, is not told that it's distributed normally, but because since n is large, okay, basically under H0, the test statistic would just be z equals to x bar minus 26.0 over s square root n, which is actually, what is n? N is actually 50. Okay. And this will just be n0, okay, approximately this is important, this is by central limit theorem. So you have to use central limit theorem here. Okay, you have to. So since n is sufficiently large, since n is large, okay, so that's under H0. That's what you're gonna do. So what we're gonna do now is essentially try and understand that the acceptance region of a test is actually bar x more than 25.1. Okay, so state the alternative hypothesis and find the level of significance of the test. Alternative hypothesis, so we already state the alternative hypothesis, so meaning to say the alternative hypothesis is less than 26, right? Yeah, so let's try and understand what's going on here. We know that essentially this part here, the acceptance regions for H0 would be x bar here, which is 25.1. Okay, so H0 is true. Just remember that H0 is true. This one would be mu equals to 26.0, and x bar is actually equals to 26.0. After which you use s square over 50. Okay, so this is the bar they're looking. So this is when H0 is true, is this side here. We essentially use this side here for H0 is true. Okay, this is H0 is true. Then what we want is actually find the significance level. Significance level would be this side here, right? So this side here, where this is our significance level. Okay, so that's H0 is true. This is where reject H now. So if this is a boundary, basically what you need to do is actually just find the area on this side less than this side here. Okay, you could actually just use your GC and just use normal distribution. There are many ways to do this. Some schools will tell you to just go back to the standardized curve, but actually if you understand the concept here, you could just use this part here, which is to 25.1, and mu is actually 26, and sigma is actually square root of s squared. So let me just 8.5. So I'm just gonna square root of 8.5 divided by 50. Okay, so this is 8.5 divided by 50. Yeah, so then we're just gonna paste this and just press enter. So this would be level of significance of the test would be 0.01452. So level of significance, let me just write this down from GC. Level of significance is equals to P bar X less than 25.1. So yeah, and after which I'm just gonna do this as 0.01452, 0.01454. Hence 1.45%. Okay, so that's how we do this third part here properly. So for the last part, I think the last part is pretty okay once you understand the third part. I mean, if you draw the normal curve out properly, should be fine. You're told that the null hypothesis changed to more than 26, right? And you're told that the acceptance regions is all the same. Then the question now is whether the level of significance would be what do you call it? Would be more or less. So what you need to do is actually just try and understand the concept here. Now that this is more than 26, initially this is 26, right? The middle one. So this is where mu. This is mu more than 20. So meaning to say you need to move the curve to this side here. Okay? Like that. So the whole curve will move to this side. Okay, originally the curve was this, but you move to the other side. So mu naught is actually more than 26. So 26 will be somewhere here. Alright. But because you have the same so I think I'll just do so this is mu naught equals to 26, right? So you draw another one. This would be like the same curve, but you move to the other side. Maybe this is like, okay, mu naught. So this is a new normal curve, which is actually mu not more than 26. Okay, great. Now the question now is would the levels, you have the same boundary, so with the same acceptance region, the same acceptance region will be 25.1. So we're going to use the 25.1 here. So 25.1 here. Okay, so this is this is basically the what do you call it? Alpha percentage in 3. Okay, but because we draw the same boundary, in other words, now this case here, this small one here, this small case here would actually be your acceptance region in 2. This is alpha percentage in 4. Okay, so in other words, the level of significance actually will be smaller. So how do we write this H now? I think by the diagram we can see mu naught H1 is less than less than mu naught. This is where mu naught is bigger than 26. Okay, so level of significance the right this is my bar. This would just be this. Okay, you could just write the normal distribution curve translate to some positive units in the x direction, positive x direction, some units in the positive x direction. Okay, so in other words, hence significance level is smaller than in 3. You can just draw the diagram and show. Okay, so this is how you do this question here proficiently. Now, any question or comments, please do let us know. Keep practicing and I'll see you in the next question.